Okay, are we back? Awesome. Cool. I got some thumbs up. All right, let me, oh, it's not letting me share the screen again. I think we need to fix the setting real quick.
Then please check.
All right. Yep. Good to go. Let's see. Okay, I think this is where we left off. Let's see.
This software bug costed three.
Yeah, we already saw that. Okay. So what else is there to do with computing in space? We've already seen that there's a lot of things that use computing in aerospace already, all the different kinds of spacecraft and space stations, and basically everything that's out in space today uses some kind of software and computers, as well as all of the different kinds of hardware and things on the ground that support all of those spacecraft and things flying in space. But there's still a lot of room to grow. There's a lot of things to be explored and to be created. So something like computing could give internet connectivity to people around the world that don't have it. And this is basically what I'm working on at Amazon. We're working on a project called Project Kuiper that is going to have a constellation of satellites out in space that basically act as a network of communications so that internet can go to anywhere across the world without needing expensive cables or infrastructure on the ground to bring broadband internet to places that may not have the money or the resources to have that infrastructure. So something like this diagram is how that happens. There's basically internet on the ground. Everything on the internet starts somewhere on the ground, and then it's sending that information across cables, even though it may just seem like stuff pops up on your screen and everything is in the cloud and it's all just wireless. Everything's actually pretty physical. The internet is all a very physical thing going in physical cables from one place to another. And we may not always think about that. But in this case, we can connect the internet on the ground to an antenna that can send all of our internet traffic up to a satellite. This satellite might send it to another satellite and to another satellite and another satellite until it's over where we are. And then it can beam it down to us with an antenna or a dish on our house or at our school or at our office or something like that. And then it can distribute the internet connectivity that way through other kinds of networking and computer hardware. You may have heard of the program Starlink through the company SpaceX. They do something very similar to this, and it uses a very similar kind of architecture as this diagram here. And they're already providing internet service to customers all around the world. And there's definitely a lot of room to grow in this industry. About 3 billion people in the world still don't have access to high-speed internet. So hopefully with Project Kuiper and SpaceX's Starlink, we'll be able to make a big improvement in that number and give connectivity to a lot more of the global population. And then there's also actual computing in space. So I had to throw it in here. Amazon Web Services has been working on actually computing things and running the cloud in space. So the cloud, which we think of as this kind of like ethereal, in the air magic thing, the cloud is also a physical thing on the ground. And AWS is trying to figure out if we can run the high computing cloud in space that could save in a lot of the amount of information that we send back down. So take some kind of scientific satellite that's up in space and is measuring the temperature of the ocean all across the world to see how ocean temperatures are changing over time. That could be generating a ton of data all the time, 24/7, All year, it's up there, taking data and creating measurements. If we can process a lot of that data up on orbit, up on the computers in the satellite, that means that we don't have to send all of that data back down to the ground for us to process and analyze back here. It's basically just happening up on the spacecraft instead of down on our computers on the ground. But that means that we don't have to translate as much between the two systems. So that helps a lot with the different kinds of communications or the amounts of things that we can get done in space, just because we're simplifying the kinds of computing that can happen in space. And then there's a ton of other stuff that's going to be happening in space, or potentially will be happening in space. And there's a lot going on in this diagram, and I definitely do not know about all of them, but there's a lot of things on the horizon in space. Things like human space flight, going back to the moon, creating a presence around the moon, trying to go towards Mars and bring humans towards Mars. There's lots of different space flight that doesn't include humans, although it's not my favorite, but that's okay too. There's different things like communication satellites, better GPS. There's going to be space tugs or things to clean up space debris, other kinds of free flying or active debris removal. Yeah, there you go. And all of these other kinds of spacecraft, every spacecraft needs its own specific kinds of computers and software to do a very specific and unique kind of job. So every kind of project here needs different engineers and smart software developers and coders to develop all of the software and to develop all the hardware for all of those systems. And then just one last kind of funny clip to end on, a look at what Hollywood thinks computing in the future could be. This is a little bit of a different take on a robot assistant in a rocket. Instead of having one that takes over your rocket ship and doesn't let you back on board, this one, they put in a humor setting so that the robot in the rocket can tell jokes, and the astronauts aren't super happy with that, as we'll see.
There is Mach 1. Everybody good? Plenty of slaves for my robot colony?
I gave him a humor setting so he'd fit in better with his unit. Thinks it relaxes us.
A giant, sarcastic robot. What a great idea.
I have a cue light I can use when I'm joking, if you like.
That'd probably help.
Yeah, you can use it to find your way back into the ship after I blow you out the airlock.
What's your humor setting, Towers?
That's 100%.
Let's bring it on down to 75, please.
Stage 2, separation.
I just love that. I think that's so funny that they gave this robot a humor setting and you can just adjust it like a knob on anything else. Like you're adjusting the thermostat and the temperature. You can adjust how humorous you want your robot assistant on your spacecraft to be. So maybe someday in a very, very far off future of computing and spaceflight, we will have something like that. Okay. That is the end of what I have for this talk. I have some of the different kind of experience points that I can talk to listed here. I put my email, and you can also find me on LinkedIn. If you ever have other questions, please write it down and just send me some questions. I'm happy to always answer those or engage and talk about engineering things. And I tried to leave some time. I think we have 10 or 15 minutes for some different kinds of questions. I'm happy to answer anything related to space or engineering or computing technology, anything like that. Yeah.
Can you tell us something about International Space Station?
Internet on the space station?
Yes.
Sure. Yeah, so space station connectivity used to be very not very fast. Astronauts have always had a small little personal laptop on the space station, and they used to be able to send like emails to their loved ones or do phone calls over the internet to the space station, and it wasn't very good. But now they have pretty good internet connectivity. They can get Netflix and stream music or stream different data pretty much just like anyone else. And I know that you didn't ask about this, but you know, even pushing this into the future, if we ever send humans towards Mars, the further away from the Earth you get, the longer it takes, the longer the amount of time it takes for that information to actually get to you from one place to the other. Even radio waves that are moving at the speed of light, it takes some amount of time for things to move from one place to another. So when you're pretty close to Earth in low Earth orbit, where the space station is, or where all of the satellites that I work on are, it's not a very big amount of time that you're waiting for your message to go from the ground up to space. But when you're going all the way from the Earth out to Mars, it can be a couple minutes potentially that you're waiting for your message to go all the way back to the Earth, and then for that message on Earth to send all the way back to Mars. So in the future, internet on spacecraft going to Mars will look very different. You'll need everything kind of with you, so you can't exactly stream from Netflix or things like that as easily.
If you don't mind, could you share your views on India's Chandrayaan 3 mission?
Yeah, absolutely. I don't mind at all. I'm definitely not an expert on it. I unfortunately have not been paying too much attention to the lunar space race, but I think it's great. I mean, I think it's very interesting that it came right around the same time that Russia was trying to land another lunar lander around the South Pole, and they did not succeed. So I wonder if there was a little bit of like pressure and too much of a rush trying to get there. But I think, you know, what I heard and what's really impressive about this recent ISRO mission is the cost of the program, the budget that they used to land something on the South Pole of the moon, where no one has landed anything before. I think it's pretty incredible. Over here in the United States, we have NASA, and NASA has done some pretty cool stuff, but NASA definitely spends a lot of money and takes a lot of time to do those things. So I think it's great to see, you know, more people participating in space throughout the world. I think the best part about it is that it's cooperative. If one country is good at one thing and a different country is good at another thing, they can both work on what they're good at and combine it, and everyone wins. Everyone kind of gets the best of both worlds. So I think it's great. I think, you know, happy to see more people, more countries getting involved in, you know, spacecraft, space flight achievements. I think it's great. Yeah.
Hello, hi, I am Absar Ahmed, and my question is that can you share your views that what kind of project that you are working?
Yeah, so right now I'm working on the satellite internet project. I think it's great. I mean, I'm really excited to see the impact that it will make. I'm really hopeful that projects like Starlink and Project Kuiper or other satellite internet projects are able to make a really positive impact in people all across the world. Specifically, I think, you know, places like schools that don't have access to broadband internet or internet connection, giving them a pretty low cost way to connect to the internet with everyone else. It'll open up doors to all kinds of education and benefits to them. I don't want to sound like everything is perfect, and I think everything is great. One thing that I also feel pretty strongly about is that space is getting a little bit crowded, and we're putting a lot of junk and we're leaving a lot of our junk in space. And that could become a big problem. If things collide together in space, they can create a ton of pieces, like thousands of pieces that go off in every direction. And then if any of those pieces hit something else, it can just start this big chain. So I'm definitely a little bit concerned, I think, of things getting too overcrowded, especially when we're putting up these really big constellations with like thousands of satellites. We're adding a lot more stuff to space, which is really cool. And also, I think it has its downsides. So cautiously optimistic, I guess, is how I feel about this project. I definitely enjoy the project that I'm on, and I think it'll make a difference someday that I feel good about. Yeah. I don't think I can hear the microphone. Did the microphone get turned off or something?
Hello, can you hear me?
All right, now we're good.
What do you know about the work of AI in space?
I don't know much. Let's see. So I think AI is going to become much more powerful and much more useful in space. So specifically, the things that I have looked into and learned about is human-computer interaction. So how AI can be useful to humans in space and systems like that. But AI can also be used for a lot of different things. I mean, I see applications to AI for collision avoidance, making sure that spacecraft don't collide into each other, and automatically planning maneuvers so that the spacecraft can miss each other if they are going to collide. I see applications for humans and computers interacting on like deep space missions. So when we're going to Mars, communications could take a few minutes to get back to the Earth and then back to Mars. And if we're having an emergency situation on board, we don't exactly want to be waiting, like a few minutes for our message to go back and then a few more minutes to get our response. We need everything to be with us right there. So an AI assistant could be programmed to help in a lot of different emergency scenarios, or just any kinds of procedures that you would need to be doing on board. It can basically be a helper or a tool to the astronauts on board. So I guess, AI is definitely a very cool thing, and it's becoming much more powerful. And I'm really excited to see where it goes. But it's not exactly at the level yet where we have those smart robots in our spacecraft that are controlling things like we saw in those video clips.
Hello, sir.
Yeah, hello.
The signal from the space to the Earth can be hacked or not?
Sorry, what was the last part? It can be what?
The signal can be hacked or not? That coming from space to the Earth.
I'm not sure I understand. Sorry.
My question is that why the people are trying to reach on the south of the moon?
Why are people trying to go to the south of the moon? That's a really good question. And I do know the answer to that part, actually. So if we take the moon is like a ball out in space, and we have like a light source coming from the sun, around the edges, there are going to be some parts that are kind of light and kind of dark. And if we have a crater, the lip of that crater is going to be sticking out from the surface a little bit. So it's going to kind of make a hill. And that hill is going to cast a shadow into the crater. So that crater is going to stay dark. And if we have these craters all the way down on near the pole around where the moon is rotating, the shadow is going to cover the entire crater, and it's going to stay covered no matter what direction the moon is rotated towards. So that means that these areas inside of craters near the pole can be permanently in shadow. And when they're permanently in a shadowed region, it can be super cold. It can get to even colder temperatures. It can get to a temperature so cold they call it permafrost. It's permanently frozen. So there's actually water molecules that are frozen into the lunar regolith, the lunar dirt on the surface in those craters, and it's super, super cold and very challenging to get there, and very challenging to get anything to work in those kind of environments. But hopefully we can get water from it. And the reason that water is important, obviously, if you can get water on the moon, then you don't need to bring it with you. Humans take a lot of water. Humans require a lot of water to stay alive. And also water, if you break up the hydrogen and the oxygen, and then you recombine them back together, you can get rocket fuel. So technically with enough water, you could get rocket fuel to fuel up kind of like a gas station on your way to Mars. So a lot of places looking for water on the south pole of the moon. Yeah, I think we have time for hopefully one or two more.
India's spacecraft Chandrayaan has reached moon's dark side. Russia also tried the same thing but failed. Now, what's the chance of discoveries? What could be found or seen on that barren side of the moon? Have you got any idea? Instead of water.
Yeah. I don't think there's going to be too much else. So, you know, I think we understand the moon pretty well now. Not like super, super well, but we have put different kinds of spacecraft all around the moon and taken pictures at least. So we know like what the backside of the moon looks like. We know what the poles look like. You know, NASA and India and Russia have all done different kinds of survey missions to try and find good landing places that they care about. So I think they know hopefully what's out there, and it's more so about trying to get actually onto the surface to find stuff. Yeah. Maybe they'll find something exciting, you know, who knows?
Sir, Assalamu alaikum. I am Shiraz Ahmed. By launching any spacecraft, it causes a lot of pollution. So is there any another way to send a spacecraft which is cheap and less fuel consuming and environmental friendly? Is spacecraft is working on electric vehicles?
Yeah, I think that's a really good question. So here's what I'll say. Rocket flights do take a lot of fuel, and they burn off and give some kinds of exhaust. There are not that many rocket flights that are happening around the world even. So, you know, if you take the amount of like airplane flights, that gives quite a bit more pollution and environmental concerns than rocket flights do. And then even like personal automobiles, cars around the world or in bigger countries, those can have even more kinds of pollution and things than aerospace or aircraft or rockets. So, you know, hopefully that's to say rockets aren't the biggest part of the problem, and maybe not the biggest place that we can make improvements. But yes, it is definitely something that people are working on. People are always trying to make rockets a little bit more efficient so they can get more performance out of the same amount of rocket fuel, trying to make them more environmentally friendly. You talked about electrical propulsion. So there's been a lot of research very recently on ion propulsion, which is basically using electricity to ionize, to apply an electric field across some kind of a gas till it becomes ionized. And then you can shoot that out as like a stream of these ions, these particles, as a very low thrust way of getting power. that's kind of been theorized for like super long distance travel where you don't have a person on board and you can just be slowly accelerating for like years and years and years. It's definitely very early stages. I don't think it's been proven in any actual spacecraft yet, but it's definitely something that people are looking into. I don't know, maybe someone in that classroom will work on electrical propulsion someday. That'd be pretty cool.
Yeah, I am Dhani, and the Chandrayaan recently found sulfur on the south pole of moon, and they are making a big deal of it. So why is it so? Why are they making this? Why are they making this?
Yeah, I don't exactly know. I don't exactly know, I guess. I don't focus too much on that mission. I think, you know, so what's exciting about it? It's exciting to have a new country in the race, you know, a new country landing something on the moon. That's always a big exciting thing. And they're the first ones to be landing around the South Pole. So I guess kind of everything that they do there is a first. Any kinds of you know, scientific data that they find, it's going to be interesting, it's going to be exciting to someone, and it's going to be good data. I guess I just don't know too much about the specifics of it though. Yeah.
Assalamu alaikum, sir. My name is Muhsin. So my question is that according to your view, can we human being successful in colonization on Mars?
It's possible, absolutely. It is definitely very far off, I think, like very far in the future. And I don't think it is exactly gonna save all of our problems, right? It's not a great fallback plan or something to try if Earth doesn't work out. But yes, I think it's definitely possible, and hopefully we will have a more continued presence of humans out in space, out on the moon, and then eventually out on Mars. Yeah.
Well, you have said you have used the word of James Webb Telescope in your presentation. Can you tell us what is the work of James Webb?
Yeah, James Webb Space Telescope is a pretty new spacecraft. It's basically this very big camera, and it works specifically in the X-ray the X-ray and the radio wavelength parts of the spectrum. And what James Webb is trying to do is it's trying to look super far away. And because light travels at a speed, it's not just instantaneous from one place to another. It takes time for light to travel distances. And that's what like a light year is. A light year is the amount of distance that it would take that light can travel in 1 year. So if something is 1 light year away, the light that we are seeing here now is the light that was given off of it a year ago. So we're essentially looking at that thing from a year ago. We're almost looking in the past. And what James Webb is trying to do is do that to a really big extreme. They're trying to look, you know, billions and billions of years in the past, billions of light years away, to try and see what it was like very close to the Big Bang, closer to the whole universe forming, and trying to understand how galaxies formed and stars and things like that. Yeah, so they're looking very far away in a couple different parts of the electromagnetic spectrum, and they're hoping to get some really cool data out of that. And I'm sure that they will get some pretty cool data for the coming decades. Yeah.
Hello, sir. Good morning. Hope that you are good. I think maybe Chandrayaan-3 was the first to land on the dark side of the moon. So why it is hard and difficult to land safely on the dark side of the moon? And why it is important to discover the dark side if there's no light and no any work to do with this? Thank you.
Yeah, so I guess I'm going to hit on the last part first. Why is it important to go there if there's no light? Well, specifically, we want to go there because it's really cold, because there's no light, and because there will be ice there. So that's why we want to go to the dark part. Why is it challenging? So orbital mechanics is hard, and basically when we're going from the Earth to the moon, it's much easier for us to be flying around the moon around the equator, kind of how we would fly around the Earth, rather than up over the top and the bottom poles. So it just takes a little bit different kind of maneuvering, and it's also harder to get communications. You need to be able to see your spacecraft. So when it's on like the other side of the moon, you can't talk to it. And then when it comes back out, you can. And when you have a spacecraft going up over the top and down past the bottom, it limits the amount of time that you have to talk to the spacecraft during those important times when you want to be landing towards the poles. So it kind of just adds a couple different bits of complexity there. Yeah.
Sir, as on Mars there are freezing lakes, and same on Moon. So why SpaceX wants to make colony on Mars?
Yeah. So there's not much water anywhere, right? There's some evidence or traces of water on Mars. There's some evidence and traces of water on the lunar surface. So why Mars? Well, Mars is definitely a better candidate for terraforming or repopulating. It's a slightly bigger planet. It already has a bit of an atmosphere, even though it's much, much thinner than the atmosphere that we have here on Earth and that we need to live. What else? I don't know. It's a closer temperature. It's closer to us in gravity. I guess it's just a closer Earth-like planet, right? The moon is pretty desolate. There's not too much there. And it would take a lot of work to try and terraform it into a more habitable place. But Mars is definitely not close to that either. I think, you know, you can already tell that it's pretty far off from being terraformed on Mars and everything. Yeah.
Sir, the communication between space or Earth can be hacked or not?
Sorry, what's the last part? Can be
hacked or not? The communication between space or Earth can be hacked or not? Hacked.
I guess I'm just not understanding that word. Sorry.
His mean is that when we send signals to the moon, and we have a communication medium like satellites, we are sending data and all these things through the signals. So is there any possibilities that someone like can hack the signals and interrupt the signals?
Hacked. Yeah, sorry, I was not thinking about hacked at all. Yes, you can definitely hack communication signals. That's my fault for not understanding that. Yes, you can definitely hack signals. So, you know, anything, that's a big discussion all in itself. Computer security, how to secure your communications and things like that. Essentially what we do with that is we basically wrap all of our communications in a secure key that only we have access to. And then on the other side, when we receive that message, we're able to basically unlock the message with the key that we have that no one else has. So, you know, even the messages that I work on at work, I'm working on an application that sends messages from the antenna up to the satellites. And all of the messages that we send are encrypted, so people can't just, you know, pick it up with a radio wave and see everything that we're saying. And also they are encrypted, so you would need a special private key to be able to get it. So yes, there's definitely a couple different ways that communication signals can be hacked or jammed or spoofed, different kinds of ways that you can interfere with that. Yeah, it's definitely a consideration that you need to
We would
plan
have
for.
last question for today's
Sure,
session.
absolutely.
Sir, I'm Mohammad Uzaifa, and my question is that unlike Earth's ozone layer, there is no protective layer on Moon. So suppose if we find water on Moon, can we actually live on it?
Yeah, that's a really good question. So the water that is on the moon it's not like a puddle or a lake or a block of ice or something that we can just chip out and bring back with us. It is like very small, microscopic bits of water frozen into the ground and frozen into the rocks and stuff. So it's going to take a very specific chemical process to extract that water out of all of the lunar surface. So it's going to be really hard to get in the first place. Second off, it is still unknown how clean that water is and whether it will need to go through more of a process before it's safe to drink or safe for humans to use for different things like cleaning. And yeah, there's probably just not enough. There's really just not a ton of water around the moon for that. So I don't see it being like a super big source of water for like humans to live off of in the future. But potentially it can be used for creating some rocket fuel in the south pole of the moon, where we may not want a ton of humans to be all the time anyways, because it's super cold and dark out there.
Okay, sir, thank you very much. I would like to say thank you on behalf of students and school management for all the time and efforts you did for today's presentation, because the presentation I saw you made was really impressive, and it was really hard work to make this type of presentation. And I hope in future we would have more session with the students so they can learn from your experience as well. Thank you so much.
Absolutely. Yes. Thank you for having me. This has been a super fun experience. I've been looking forward to this. Sir. And you got to see kind of the first run of this new lesson. So thank you for being the first time that I get to go through this. I appreciate it. It's been a lot of fun.
Thank you. Have a good day.
Thank you.
Thank you. Have a good bye.
Bye, everyone. Thanks.
Thank you. Long.